All right, let's get started. Thank you everyone for coming. My name is Roberto Silva. I'm the new Library Studio Manager for the FBRI Health Sciences and Technology Library, the branch right here down the hall. This is our first in-person workshop in collaboration with FBRI and the Library Data Services team. So I'm going to leave you with Dr. Ann Brown, who will introduce our presenter.
Yes, hello everybody. I hear I'm just coming through the speakers, but I'm Dr. Brown. I'm excited to be here and welcome you all. We are doing this hybrid style so that we can learn how to do this effectively in the future. So please bear with us as we learn on all these new angles of how to get content out to you fine people. But hi and welcome. I'm Dr. Brown. I am an assistant professor here at Virginia Tech and science informatics consultant in university libraries. And I also work in the Department of Biochemistry and the Academy of Integrated Science. I'm super excited to be here with you all today on the Zoom side of things and run things over here. So all Zoom participants, y'all can message me and I'll take care of everything on the Zoom side. In-person participants, I give you a very friendly wave and hello. But we're really here today to start thinking more about data science and the biomedical sciences and learning the tools and techniques that can make us better researchers, better clinicians, and more. I'm very interested in data reuse and reproducibility and how we can actually study all these things as well. So with that being said, I am very happy to introduce you all to Dan Chen, who is going to be your workshop leader today. Dan can tell you a little bit more about himself, but he is a master of R and Python. He's written books in this and has worked at RStudio, so he is highly competent and a great resource and loves educating people on these tools and has crafted his own dissertation on these topics. So let's all give Dan a round of applause for teaching us these next 2 days and thank him and for introducing himself. So thank you very much, Dan. We're looking forward to working with you.
It's so nice hearing and seeing people. um, a few things. Oh, hold on, let me just make sure there's. Let's move Anne out of the way. So, a few things that you'll see all over the screen and stuff. There is a pre workshop survey. If you haven't already, please fill it out before class ends tomorrow. So you can do it at the end of today, before tomorrow. That would help all of this that we're working on setting up together um, to work properly. I am kind of confused why the captions aren't updating, but hopefully people on the other side can hear me. So this is all part of my dissertation project, which is trying to put together a data science curriculum for folks in the biomedical sciences. One other thing, since there is a hybrid session, if you want, you can join the Zoom room. And because Zoom has a chat window, if you want to, instead of raising your hand, ask a question, you can use the Zoom chat, and I will see your question somewhere in front of the screens in front of me. So you can do that. Just make sure you're completely muted before feedback, and I have no idea what's going to happen in that case. So if you want, you can ask questions through Zoom. You can ask questions in person. For the folks on the Zoom side, I will repeat the question, and so hopefully that all gets worked out. For the lesson materials, you can find the stuff that we're working on a website called ds4biomed.tech. That is essentially what is literally opened here on my screen on this side. So my notes that I'm looking at are exactly the same set of materials that we're going to be teaching out of. There are a few slide decks and papers that I reference, so you can find that on that bit.ly link. And in general, there is an open source project on trying to define technical words. Oh, I see why. Technical terms, and so there is a glossary project run by the Carpentries. So if you end up confused about what terms mean, there is a glossary that you can look to for that. For those of you on Zoom, and if you didn't know, since the pandemic is roughly coming to an end in terms of in-person and online workshops, you can have the Zoom screen on the top right corner, open up RStudio in the top left corner, have a panel for your notes, and then the Zoom participant panel chats. This is assuming you only have one screen, so That is something that we figured out early last year on how to do online teaching. If you end up going to the website and you end up seeing this error message, wait about 15 minutes. It literally just means I went to go update content on the site the same moment that you tried to join the site. The way the site is built is using R. We won't really cover about how that part gets built, maybe in a later session. But essentially all the code that I present in the book has to get rerun from scratch. So I make sure that there are no errors in the code. And so during that process, the site goes down and back up. So that is, if you ever go on the website and you end up seeing a message and you definitely know it works, just wait about 15 minutes. All of this stuff comes from a survey that I sent out before all of the materials were put together, so just as a sense of what to expect. Most people feel like having raw access to original data is good for reproducibility and for their analysis, but at the same time they don't really do their work using a programming language, and they're pretty indifferent about whether or not programming can help with reproducibility. Hopefully by the end of these 2 days, we will show you some of the skills to help you with reproducibility, if anything, just to get you to do one part of your analysis in code, and then you can go do whatever pipeline you're used to, but it's slowly incorporating these skills that we're covering. A lot of this work comes so part of the dissertation that I am working on, I realize my camera's off, part of the dissertation I'm working on involves creating personas. So these are fictional characters that represent some combination of the people here. And you don't really have to do this right now, but essentially we identified what does an academic need, what does a clinician need, what does someone who's an actual programmer need, and what do students need. And so we built the materials around these types of personas, and you are probably fit into more than one of these bins. All of the personas you can read about in the ds4biomed book. One of the questions in the pre-workshop survey essentially just says hey, who do you most identify with? So if you want to read about them, you can go there. As we get started, so a lot of these figures, so the persona figures, they were drawn by my sister, but all of these R-related figures are drawn by by Allison Horst. She is also a statistician and researcher. I forgot what university she's in, but she drew a lot of these figures for the R community to use, and so I took them. So as we get started, yes, the journey of learning how to program is going to be hard. Hopefully we take you to this happy medium on this first hump over the next 2 days, but I will just tell you right now, you're going to get to a point where everything that we teach you in the next 2 days is going to hit a limit, and you're going to have to find and learn on your own, hence this first drop-off. But there are a lot of resources and a lot of people around the community that can help you. Twitter is one of them. One of the slides at the end of the day tomorrow, it literally gives you all of the other resources where you can ask for help. So, all right, another cartoon by Allison. Coding is difficult. The computer will do exactly what you tell it to do. If you spell something wrong, it will do something wrong. So this is sort of the phases of coding that most people, myself included, go through. And it's really just an illustration saying that it's okay as you're starting out, especially if you're following along with the code that I'm writing. Most of the issues in the beginning is going to be some type of typo. So you either type something wrong or you type something and didn't run it. And so the next line sort of didn't incorporate the things that we are using. That's going to be most of the problems that you end up, especially in a classroom setting, but stick with it. There are people that can help you with things. And so we believe in you. So there's a lot of things in the R world. The journey is going to be, it's not going to be simple, but hopefully we've sort of lowered the on-ramping of difficulty for you to learn all of this material. So expectations for today and really tomorrow. There's a lot to cover. I don't expect you to take whatever project you're working on now, rewrite the whole thing in R. Think about the overall things that I'm showing. Maybe there is a portion that you can utilize right away, and then maybe that is the first part that you use in R. When I first learned R, literally the only thing I used it for was I had one column of values, and then I needed to convert it into like a 3 by whatever matrix of values, essentially just turn a row into a grid, and that's all I used R for. And then I dumped everything back into Excel. So if you end up finding that like, hey, this simple transformation is really easy to do in R, just add that into your pipeline, and then slowly you'll end up just using the programming language for all of your work. So the syllabus. So today we are hopefully going to cover everything we need to get our data into R, run a few descriptive calculations. I believe the way I've set up the time blocks, so there's more time for visualization and statistics tomorrow. We'll go through part of the slide deck for cleaning data. And then for tomorrow, it's really like the heavy duty, like how do you manage your data, process it, and then how does that all fit in the things that we're learning today and the first hour tomorrow into visualization. So how does ggplot2 work? And how does data fit into what we need for running statistical models? All right, so any questions so far? The other thing, if you haven't already, hopefully my computer is also burning up because there's so many things open right now. But if I think if you had any issues with installation, do let me know. We do have a backup system that you can use. But with that, let me just open up the next slide deck. I just want the button. I just want the button to say present. No, I don't want you to stop. Oh, yay. Fantastic. If you haven't, if you have the ability, I would say take out a piece of paper and a writing utensil, because the first part is sort of a thought exercise, but if you do have something to write with, it would be a little bit useful as I go through the examples. And this is also a way to stall to make this load. or we can forego the slide deck, and hopefully that will eventually load up, and I will just present straight out of the materials here. It should be fine since the slide deck were literally screenshots out of this page anyway, so I will be able to manage. Okay, so the first topic that we're going to talk about is setting up spreadsheets. The goal is, or the way the materials are structured for these 2 days is, I am assuming you're starting at a point with, I have data and I want to do something with it. A lot of other courses essentially start off with, here is data that we have already prepped for you, and then we will teach around that, versus trying to teach you around something that you can work on your own right away. Has this loaded up yet? Oh, yay. Okay, so first exercise. Let's say we have a mock clinical trial. One of the things that happen in clinical trials is they sort of give you the experimental drug and then take blood draws of you over time, usually over the course of a couple of days. These blood draws happen every 15, 30 minutes to an hour, and it just happens, you're literally just in a room, and the clinical trial folks in the room that you're in sort of just do blood draws on you. So let's say you, for example, have 3 patients. There's Gemma, Priscilla, and Anya, and how would you structure your spreadsheet such that you are capturing the time, the heart rate, the respiratory rate, blood pressure, pulse ox, and temperature? So I will give you about 15 seconds on your piece of paper or in your head. Think about how you would set this spreadsheet up or set up this data set. Also knowing that you're going to have to take multiple readings in the future for each of these people. And you don't have to worry too much about the actual numbers. They're sort of just there as an example if you need to fill something in. So one thing that you could have done is each of those things that I mentioned literally becomes a single column in your data set, right? So you have a whole column for name, a whole column for time, whether or not that's in 24-hour or 12-hour, that's up to you. You have a column for blood pressure, et cetera, et cetera, et cetera. So that's totally fine, but one of the things when you're putting together a data set is if you ever look at a single cell of your data, think about what information is captured in that single cell. Right, so a good data practice is really, if I pick out a single cell, it should really only represent and contain a single thing, right? Other things like the temperature is a bit ambiguous. Like if you're in the United States and you see a temperature reading of a human being being 97, it's probably not in Celsius. But if you are working with instrumentation data or you're like taking temperature readings out in somewhere in the world, 97 could be, depending on what you're measuring, it could be in Celsius or in Fahrenheit. You don't know. So one thing that would be useful here would be, I need a way to capture the unit along with the actual value. The other thing that is in this data set that sort of, it could be a problematic thing in the future is if we look at the blood pressure column, we simply put in, for example, 128/78 as the actual blood pressure. But if we only wanted the systolic readings over time or the diastolic readings over time, there isn't something that we can do right away without doing some kind of processing to fix that, right? In your head, you can do something like, just as a heuristic, okay, we have to do something to split the two parts by that slash, right? Same thing goes with name. Typically, we want to be able to filter by first name or last name, not just on their entire name by the first letter of their first name. So that's something that you might want to think about as you're curating and putting together your own data set. So one other thing you can do, we talked about units. So pulse ox, we can put the percent sign in there. Temperature, we can put the actual F. That's one way we can fix it. But we sort of now introduce another problem into this version of our data set, because now if we wanted to say something like, give me the temperature column and then take the average of that column, we can't really, because 96.8 F is not a number. It is a number and a character, and the computer, including Excel, will treat it all as a character, right? So that ends up being a problem. Also, if we now look at 96.8F, remember what I talked about in terms of things only carrying one unit of information. So that value now contains the actual value of the reading, but also the unit of the reading, right? And so that is another thing you want to keep in mind. Like when I say each cell should contain one thing, I really mean each cell should contain one thing. And that includes units. So another thing that you can do, like I mentioned, you would want to split the names of the people into two separate columns. So you have first name as a separate column with last name. In this part of the data set, you still see that this is sort of an example of what you may or may not have done in your head or on a piece of paper. But you can still see here, blood pressure is still one reading instead of two separate parts. And so another thing that you can do is now take all of the unit information and simply stick it into the column. So that prevents it from being part of the actual reading itself. Like for here, I realize I just forgot to take out the F. But this way, if you can pull out the entire column, treat the entire thing as a number, and Excel or really any program will be happy. Also, because the column name or the units that you're working with is part of the column name, it becomes way less ambiguous, especially if you start dealing with multiple team members. You could have someone from anywhere but the United States working on your data set, and they just take all their readings in Celsius. That is something that you can capture or recognize right away. Like if there's any reading under like 80 degrees, it's probably in Celsius. So you would have to do another conversion step, but if you are thinking about, I just want to curate my data set properly the first time, this is something that you can do. The other thing, like I had mentioned, you would want to split the two parts of the blood pressure, and I think I actually flipped the two, into separate columns, and that is all because you can take entire averages or whatever statistic that you need on an entire column, and if you really need to, you can join them together, but keep them separate as you can, as much as you can. For things like temperature unit, if you do know that you're going to get mixed readings, it is beneficial to have a column that is just dedicated for a particular unit. That way you still have the ability to take an entire column, do an average right away, or if you need to filter for like the people for some other reading or another, you can essentially filter your data set for that. So the main takeaway here is, as you're curating your data sets, put one thing into each column, and really only one thing should be in each column. Each cell should really represent a single idea or a single reading. And so if we think about the problem that we have right now, which is curating together that PK study, what would you do now that you have multiple readings? So I'll give you about like 30 seconds to think about how would you add more data to the version of the data set that we put together. So one thing you can do, if you end up in a situation like this, and the ideas that I'm presenting, none of them is like the solution to things. They're really just different ways you can think about your data set. But one thing you can do is make an entire different, either a separate Excel sheet or a separate Excel file for each of your patients. There are some benefits to this. You can, if you have to ask the question about how does a certain value change over time for each person, this is a way you can set up your data set such that you only have to look at or worry about one person at a time, and you can quickly do those calculations. Just know that if you need to make a calculation of what is, for example, the average heart rate for all of my patients all together at one time, that becomes a harder problem because now you have to figure out a way to join or combine all of those separate files into a single file. One way doesn't mean it's better than the other. So if you download like stock data comes in like, here's the stock pricing for like whatever time period, like for each day. That's how you get stock data. So certain systems store data in one way. If you want to do aggregate counts for multiple days, for example, in stock data or in patient data, you just have to keep in mind that is probably another step that you would have to do or think about. One other thing that you can do, I said there's like examples of bad things and nothing's really wrong. Like this is one example of something that's wrong. What people end up doing, especially if you're manually inputting stuff into an Excel spreadsheet, is, well, I still want the flexibility of doing individual people calculations, but I want them all in a single spreadsheet, so I'll just have a bunch of blank lines that separate between people. That's fine. That sort of solves some of your problems. In terms of you can do individual people calculations, you can see whether or not someone's missing or reading. But the problem is when you load this into a larger data set, all of those blank rows end up showing up as like blank rows. And if you are an analyst and you've just been given a data set and it's like, oh, here's my data, go analyze it, and I see a whole bunch of blank rows, I am going to be a little bit panicked because I don't know if it's, did you leave those blank because you needed a visual marker between different people, or like you just didn't have time to fill in those values, right? It's super ambiguous what that could mean. So you really don't want to have blank rows. The other thing that you can do, and this is an example of another thing that you should not be doing, is instead of stacking your patients one on top of the other, you stack them sort of column-wise, like next to each other. This is something you have to be very careful about because most people don't know about this, but a lot of data systems have an absolute number of column limit. It's harder to see a row limit on things because people expect millions and billions of rows, but the way data gets stored a lot is they don't expect you to have 1 million columns of something. Don't really like using, I'm trying to find non-COVID related examples, but this exact problem happened last year in the UK because as they were collecting COVID case counts, each day was its own column for each county. And then what happened? They ran out of columns in Excel. And so their entire system stopped updating because that whole system ran out of columns, right? So it is really weird to think about that you are trying to input data, but then all of a sudden you run out of columns. It is sort of a weird thing to think about that can happen, but it does happen. And that's why you do want to think about having your data stored row-wise as much as possible. And if you end up in and it's pretty rare that you'll have like that many columns. One big example where you would have that many columns if you're running like a GWAS study where you have like SNPs for whatever thing that you're looking at. Yes, that's probably true, but that's also why they end up storing things in different formats. And it's not like, oh, here's my genetic data, here's an Excel file. It's usually some other file type that understands that you have all of these columns. For the most part, if you open up some of these files, especially like some chemistry files, like, yeah, they take what you would think is stored in columns, but they store them as rows. So they essentially do a transpose of that data. And it's because most systems, if you were to load it up into a spreadsheet program, Sometimes Excel won't even open up the file and be like, I ran out of columns. I don't exactly know what letter it is in Excel that the actual limit is. I'm sure you can look that up, but yes, so keep that in mind. So another thing you can do is really have all your patients stored together in a single data set without row line breaks or anything. This does make it a little bit harder if you want to parse people out. So for example, if I just want all of the data for Gemma, it's a little bit harder in this scenario. But even if you think about using Excel or whatever spreadsheet program you're working with, it's easier to say, give me all of the rows where the person's last name is done, and then you can run your calculations that way. So you have mechanisms if everything is together in a single data set. You might have to go through other steps, but think about which steps would be harder for you to do and which steps wouldn't be harder for you to do. So that very first example of having people in separate files, maybe it's easy for you to combine everything together and do the calculations afterwards. That could be something that's easier for you because now it's easier for you to double check who has a reading and what time or not. So the other main takeaway here is if you plan things out accordingly, there isn't really something as messy data. A lot of times you get someone else hands you a data set, they didn't think about any of the problems that we just talked about, and so that's where the problem ends up. It's like, oh, like I need to take all of these only systolic readings and you just dumped everything into a single column, but that's like part of the main research outcome that we're looking at. It's like, why did you do this? That's sort of when you get really frustrated and you're like, this data set's a mess, right? So if you plan things out, especially if you have the option to curate your data set yourself, think about having all of those components that we talked about, or how you might go about doing that bit of the analysis, because it will save you a lot of time. So for the next exercise, let's say part of your study has this set of rules about what ends up being a abnormal observation that you would have to report. So blood pressure greater than, any part of the blood pressure where it's greater than 140/90, some resting heart rate that's greater than 90, respiratory rate over 20, pulse ox under 95, temperature over 100 degrees. How would you flag that in that data set that you have in your head? I will give you about like 10 seconds because usually people have like their own thing that they're used to. So one very common solution is literally find those bits of your data and then use a color. But what did I say in the very beginning? If I take a piece of any of those cells, it should really only represent one single thing, right? So if I look at that last row, that 142 is colored. So what does that red color mean? It means that that's a reading that I need to report, right? So now there's 2 bits of information in that cell, which is fine if you're working with Excel or you're using your data set as a visualization that you want to flag. That's totally fine. But in the actual data set itself, there is no part in that row that says like this is a problematic observation because you're using a color to denote that, right? So if I were to print this out on a black and white printer, I wouldn't know that there's a problem here, or I would have to look harder. And you using your colors was really good for your visualization at your desk, but it doesn't mean it's how you should be storing your data. That's sort of another reason why when I work with people, I try not to work in Excel files because it's really easy to add these features into an Excel file, and if you start passing around CSV files or things that are just plain text, it's hard for you to save out that color information, and it'll force you to think about storing your data better. And so this is all from the perspective of I have a data set and I want to do something with it, right? So that's totally different from like someone else giving you a data set. Maybe they give you a data set with color in it, and so now you need to parse out that color information for something for you to do more work with it. So one thing that you can do You can also do this along with a color, like make a separate column that says like, this is a column or an observation that needs to be reported. You can put yeses and no in there, and then use a color column in there, because now the actual information that you want to capture is already captured in a column, right? So now I can really say like, filter out all of the rows in this data set that have a problematic reading that I need to report to the IRB for some reason or another, or the actual pharmaceutical company. That's much easier to do. It's also in your data set. You don't risk exporting out your data set, all the color gets lost, and all of that time you finding out which values need to get reported, you have to do it again, right? So the more you have to do something, or if you're doing things by hand like that, it's pretty common that you will make a mistake or you forget something, and then reporting gets not done properly, et cetera, et cetera, et cetera. So the other thing that you want to do is treat your data set as an actual piece of data. It's really, and this happens to me as well when I look at just a spreadsheet or a wall of numbers, like I try to add bits and pieces in there. So you don't want to treat your actual data as a visualization, treat it as a piece of data. And that's sort of like where, if you start doing this stuff in Excel, and at a certain point you're now fighting Excel because you're trying to do things that data itself isn't made to do, because you're trying to treat it as a visualization. So the last part of the exercise, what happens if, one of those readings and you go talk to the patient, is like, they're actually fine, and they're like, oh, I was just doing jumping jacks and yoga because it gets the blood moving, whatever. How do you report that in your data set? The main thing here is really give yourself a column to take notes. That's always, especially if you're in a process of manually curating data, give yourself a way to take notes. Maybe as you're taking notes, you'll end up realizing, hey, I might actually need to create another column to create tags or something. Give yourself that kind of flexibility, and that's totally okay. But just realize that the actual main pieces of your data, only one little bit of information is stored in there. So you're not, relying on parsing out individual cells as you're working with your own data set. So in summary, spreadsheets are fine. Usually if you work with other people who are analysts or other data scientists, they talk very ill about Excel and stuff like that. But in reality, like, we all use it, especially if we're manually curating data, so it's fine. Excel is sort of like the graphical user interface to your data. You can totally program in Excel as well using VBA. You will eventually hit a limitation, or things get more difficult, because that scripting language in Excel is programming how you would be clicking through the interface, not actually working on the data set itself. So that's why some people who end up, you can do amazing things in Excel and programming using VBA, but that's why things feel a little clunky, because you're programming the clicks that need to happen instead of just working on the data directly. That's sort of an oversimplified statement, but that's roughly where that's coming from. So it's okay to use Excel, just keep those practices in mind, especially if you're curating your data. Really, the main takeaway is, if I take out a single number out of this data set, it really should just be one thing in there. And that is going to be a point that's going to carry over all the way till tomorrow afternoon. And so certain things that you can identify as like not being great in a spreadsheet program, and then hopefully the skills that we'll cover will make that easier for you. All right, so the next thing, we're going to work with RStudio a little bit. So if you haven't already, hopefully you have R and RStudio installed. Don't worry too much about the actual R version. The main thing is there was really one library that you needed installed. Technically there's another one, but we won't really need that until tomorrow. So once you have RStudio installed, this is generally what RStudio looks like. You have on the left-hand side, the console. So this is where actual code goes. If you want, you can use R as a glorified calculator, right? So if you type something in the console portion, it will run that and give you the result back. On the bottom right panel, there are a couple of flags or tabs. One of them is the files panel. So this is where you can find files around on your computer. For the Windows folks, the starting folder or the home folder is technically in your My Documents folder, which is kind of a weird quirk with Windows. So if you ever end up like, I just want to go to this folder and I don't want to use this file pane, this works for if you're on a Mac as well. On the right-hand side, there's these 3 buttons. And if you click that, it'll give you a little go-to folder or some kind of viewer or your Finder viewer. So if you know how to navigate to your folder on your normal computer, you can click those 3 buttons and it will navigate there for you so you don't have to use this file pane. On the top right panel, we'll see this when we load our first data set, but all of the data sets and things that you create in R, or really in RStudio, will show up as a list up here. So if we load up our spreadsheet data, which we will in about like 10 minutes, you can click this or view it so you can get your spreadsheet view in RStudio, and then you can work with your data in code or typing the commands, but you still have the benefit of seeing it in spreadsheet view, because sometimes we go look at spreadsheets to spot check to make sure things are doing things properly. Another thing with RStudio, so if we go to the top right corner, there's like this little paper with a plus. We can click that arrow and go to RScript, and that will open up a 4th panel in RStudio eventually. It's going to do it twice. And so this panel that shows up, by default, it's called Untitled 1. So this is where if you're writing code and you want to save it for later on, this is where you would write and save your code. One of the things as we're working on today, you can write the little hash symbol, and this will be a comment. So that is a comment. And so if you try to run this, so how would you run this? One way you can run it is you can hit Control-Enter on that line, and it will try to run that. Comments are lines of code that don't, where's my mouse? That if you try to run it, nothing happens. And so I can then type something like 3 plus 10, and so it will run the 3 plus 10 part, but it won't run that comment. So as you're taking notes and if you're typing along and you're like, oh, this is what that thing does, totally okay to write a comment to yourself of what that thing is. And last but not least, as a basic intro to R, you can save these files just like any other thing on your computer that you're used to. So I'm going to dump this on my desktop for now, and I can say this is like 00 first script. So one other thing that you'll notice is don't use spaces in your file names, even though you can. The more you work with programming languages and coding up your examples, you'll find that in order for you to tell the computer that there's a space in a file name, you have to put in a backslash. So you're not really saving more time with spaces. I personally do something like I use dashes to split off big components of things, and I use underscores for like statements. Another thing that is a good practice is if you know the code that you're going to be running is going to happen in multiple files, and there's an order to those files that you need to run them through, start them with a number. On top of that, start them with at least a 2-digit number, so 00, instead of just 1. And the reason for that is if you go from 9 to 10, 10 traditionally gets sorted back up to the top because it begins with a 1. So your computer is going to be like 1, 10, 2, 20, or something like that. So it's really going to be like 1, 10, 11, 12, all the way up to 19, then 2, 20, 21, 22, because it's sorting things by how it would in a dictionary and not realize that it's a number. So in general, even if you don't think you're going to go up to 99, I go into the habit of writing, at least starting off with a 2-digit number in the beginning. So that way when things are all in a single folder, everything is sorted in the order I need to run things in. So what is another example of this? Yes, so let's say I have an example that's like a cleaning script and an analyze script. If that's sorted on my computer, analyze comes first before cleaning. 6 months from now, you're going to come back to your project and you're going to be like, okay, I have to spend time to even figure out what order I need to run things in, versus just seeing the 00 that runs first or the 01 that runs first. And that's all nice and clean. And so that is another good habit to get into. You can also do weird things, like what I end up doing these days is I use a 3-digit number and I count by tens. So my first script will be like 010 and then 020, because chances are I'm going to forget something and I need to shim it in the middle, so I can say 012 and I don't have to renumber things. So that's just something that happens over time, and that's just an extension on top of that. But the main takeaway is have your scripts in some kind of sorting order, and your life will be a lot happier when you have to go back to this project. All right. Now I'm trying to figure out if I point you to the link, if you can get to the actual site. Okay, so if you go, you can see here at the bottom of the screen, there's a part that says ds4biomed.tech. If you end up going there and you click on the left-hand side, the data sets, we will download everything, all the data sets and all of the stuff that we need for the next 2 days. And I will put that in Zoom chat. So one of the things that you see here is there is a link to a GitHub page, and if you click that, it will take you to the actual page where we can download our data. And so if you haven't done so already, I'm essentially showing you how you can download everything that we'll be using for the class. All right, so if you end up here, the main reason, if you know your way around Git, that's fine. I'm not going to explain that. But in order to download something, if you're ever are on a GitHub page and you just need to download all of the contents of your computer, if you click on the little code button here, you can go to download zip, and essentially all of the files on that page at the time that it's like as it is right there, it'll create a nice little zip file for you, and you can download that and put it on your computer. So we will be working on that project. I'm going to save it to my desktop for now. You can put it in whatever project folder that you want. And it is a regular zip file, so once it is done downloading, you can unzip this file, which I guess is the more important thing to remember. Computers these days make zip files seem pretty transparent, and people end up working inside a zipped thing without realizing, and eventually that's going to end up causing a problem. So once you have that zip file done, just remember to actually extract it. Inside this file, one of these files is a file called ds4biomed.r project or .rproj, which is an R project file. What you can do is you can double click this and hopefully it opens up in RStudio. Another thing that you can do is in RStudio itself, in the top right corner, you can click on the project button, go to open project, and then navigate to that file itself. So I put that on my desktop, so I can go to the desktop. It is going to be called ds4biomed-learner, and then literally select that R project folder, and it will change a few things around your RStudio window. So is anyone not there? Hopefully all of that stuff got set up. I'm going to talk as this is working and figuring itself out, but what you'll notice on the top right hand corner, that instead of project none, it's going to now say project ds4biomed-learner. If you did it through Git, it's going to just say ds4biomed without the -learner. One other thing you'll notice that the bottom right-hand panel, that files panel, will now open up to that folder. And that is another nice thing about RStudio projects, is it will move everything such that that folder where that R project is considered your starting point. You'll see if you end up getting code from other people, a lot of times that first line in their script is going to say something like /home/ their username / documents and whatever file path to their data set on their computer. And then if you end up working with multiple people, the first however many lines is going to be like every person's username and direction, their path to like that file. So if you work in R and everyone works with these R projects, you don't have to have that problem anymore, because once you open up the project, everyone's starting point is where that folder is, and it doesn't matter where it is on their computer, because if you keep all of your data and your files and your code from that point on, then it's all relative. It doesn't matter where it is on their computer. So another thing, if you end up working with R, please use RStudio projects. It will make a lot of things much smoother for you in the future. One other thing before we, how are we doing on time? Okay, so we're good on time. One other thing before we go about and loading our first data set, or really before we take our first break and then our first data set. If you've never used RStudio before, or if you have used RStudio before and you never really looked at your settings, there are a few settings that I highly suggest you go through. So one of them is right here. By default, this would probably be checked off, and I don't exactly know what this dropdown ends up being. But you want to make sure that that first checkbox is checked off, like it's not checked. So it says restore .r data into workspace at startup. Essentially what this means is every time you load up RStudio, it's going to take all of the data that you were working with, like when you turned off your computer, and try to load it back in. That might be something that you says like, wait, that's actually a really good idea, except let's say you are working on a really large study and this is a very large data set. Every time you load up RStudio, it's going to spend the however many minutes it takes to load everything back up. And the other option down here, essentially, if you set it to never, is it won't even prompt you to save that R data file. Once you click out of RStudio, it'll just close it and that file won't get created. So that's just something that I do, mainly because when I open up RStudio, one, it opens up quickly, and two, it always opens up in a clean slate. Right? So as you're working with code and as you're working with projects, you might end up loading multiple data sets. Half of them you don't use. You might create variables where you don't use like any of them anymore. And so this way, when you load everything up, everything starts from scratch. And another reason for that is it now forces you to run through your code from top to bottom again. So everything is brand new. As you're debugging, you might be running like line 5 like a couple of times, and you might jump down to line 20, and you kind of lose the ordering as you try to figure out what's going on with your code. And so you might just turn everything off and turn it back on, but that turning back on didn't really reset anything. So that's sort of what this will prevent you from doing. Another cool thing some people like, you can go to appearance and change the color theme for things. I know some people really like dark moded things. Like I usually work in material mode, which is nice, but it's not nice. It's not as nice for teaching because I lose a lot of contrast on the projector, but you can change the color scheme to make this feel more like your own space. So we will take a, let's go for 10 minutes. We'll take a 10-minute break. Hopefully what you see here is you have R in RStudio, you have the data sets downloaded. You can explore the data right here. So if you click on data, you'll see some data sets in here. If you see the little 2 dots, you can go up a folder. We'll talk more about that after our first break. But if you have any questions with all of that, just let me know and we can figure that out, because if you're not here, you're going to have a hard time with the rest of the class. All right. So come back at, I think, 9 past the hour. I guess that's actual 10 minutes. So come back then and we will continue with the rest of the class. Hopefully people on the Zoom side are, my computer is still holding up on things. If you are on the Zoom side, if you can give a +1 either in chat or use the little check mark in the participant panel, that would let me know that things are okay. Cool. People are still trickling in here, so I'm going to try to load up all of my slide decks. I was originally trying to not have too many tabs open, but that seems to be not a good idea anymore. What do we do when people left? All right, let's get started. There's some people who are still trickling in, but that's fine. All right, so now we have our in our studio set up. We have all of the data that we're going to be working with set on our computer. We're now actually going to try to load this thing into our computer in our studio. If you take our courses around the university or through workshops, or you read things on your own, depending on who you are learning from, there are essentially different styles of learning how to program in R. The style or the way we're learning and the set of packages that we're using is known as tidyverse. So that is like the Googleable term that you will use if you want to follow up or learn more about the things that we're learning today. Tidyverse was originally created by, it was separate packages created by Hadley Wickham that eventually became a whole suite of packages that help manipulate data and that whole data science process. So it got a whole name called Tidyverse. And so we're using those set of tools because they work really well with one another. I personally find it much easier to teach through the Tidyverse because things are a little bit more consistent, and consistency, I will take that over many other things. I also work in Python, and so the version of working with data in R and Python is called Pandas, and after teaching both a whole bunch of times, stuff in Tidyverse in the R world is just way more consistent than stuff in Python and Pandas in the Python world. So that is my opinion. If you have opinions on your own, let me know and we can talk about it. So the first thing we're going to do is we're going to load up a data set on our computer, right? So before I even go back to this slide, one of the data sets, so we should see the ds4biomed-learner on the top right corner. We should see a data folder in the bottom right corner. If we click on data, the data set that we are going to attempt to load is the, which file is it? Give me 1 second. Is the medical data tumor growth .csv file. So we want to load up this file. So the question is, how do we tell the computer that's where the file is? This is the small discussion that we are going to talk about. So if you're on a Windows computer, look at the one on the left, and if you're on the Mac computer, look on the block of stuff on the right. Your computer has a starting point. On Windows, it's probably C drive with a slash. On a Linux or a Mac machine, it's going to start with a slash. So if you ever look at someone else's code and you see like some kind of folder path directory and it begins with a slash, probably means they're on a Mac/Linux machine. If it's something like C drive something, you just got code from someone on a Windows machine. So currently we're in this ds4biomed folder. Right now it's on my desktop. It's technically ds4biomed-learner. So when we talked about our studio projects, this is your starting point. That is known as your working directory. So that means all of this stuff beforehand doesn't really matter. Because we're working with a project, all it cares about where that folder is, and that's your starting point. So if I give code or this project to anyone on their computer, what's nice is, well, not everyone in this room is named Daniel on a Windows machine. So you don't have to worry about where people store files. You pass around projects around, so all of your code is theoretically like reproducible and shareable amongst your group. So that is the working directory. That working directory stands for where you're starting. So from where we're starting, how do we get to the medical data tumor growth file? There's two ways we can point to it. We can point to it from a relative path, meaning where we're starting from, which is our working directory. How do we get there? The way we get there is we go to our data folder, and then we can point to the medical data tumor growth.csv file. So that is what's known as the relative path. Most of the time, if you're working with people that like have data stored in one folder location, all their code in another thing, and it's really haphazard, you might see people write paths from the absolute level. And the absolute level means I'm going to tell you the address to this file from the beginning of my computer. So if you see something like /users, Daniel, desktop, ds4biomed, data, medical data, tumor growth, that is what an absolute path looks like. So the main thing to look for is see what it begins with. If it begins with a slash or a C drive or something, it's an absolute path, or you can specify things from a relative path. In general, we try to write things from a relative path perspective because it forces people to understand where the project even starts, and then you can pass around code and it shouldn't matter. You can change your working directory. Typically, you try not to, but for another example, let's say our working path is in the analysis folder, right? So we are starting from the analysis folder. Maybe that's just because, well, all my code is in here. It doesn't make sense to start from the top of my file if everything I'm working on is here. So now the problem is, how do we essentially go up a folder? And so that's where these two dots come into play. So in programming world, if we're trying to point to a file, if you see two dots, it means from wherever we are, it means one folder up, right? So if the data folder and the analysis folder are siblings, and we're inside the analysis folder, we have to go up to where the two sibling folders are. So we say ... / denotes the folder, like we're going to the next folder, then the data folder from there. Or you can specify things from an absolute point of view, so you can just specify from the top of your computer. You can do that as well. Some people do that as a crutch just to make something work right away. You can use an absolute path for, I literally see the file on my computer right here, let me just type that in, and then it's maybe something to do with your working path, or you and your computer think that you're starting different locations. So you can use an absolute path to help you fix things, and it's still there as a tool. But in general, I try to write everything from a relative path perspective. Just know that the main takeaway is the two dots means go up a folder. So just as an exercise, you can type it on your computer. You can say it in your head. Let's say we're currently in the analysis folder where demographics.r is. What is the relative path to the patient CSV file in the RCT folder, so this one, and then what is the absolute path to the patients.csv file in the chart review folder. So you can write that down on your computer, say it in your head. There are certain, and I'll show you how you can get your current path in RStudio when we actually write our commands for it. All right, so relative path. So if we're starting from the analysis folder, we actually have to go up 2 folder levels. So it's going to be ... /, then into the RCT folder, then into data, and then into patients. So the main takeaway there is ... / means go up a folder, but you can go up multiple folders, just like when you hit the back button or the up arrow or click to the left of the folders that get created when you're on a Mac machine or something. That's totally fine. And so that's why sometimes you'll see a whole bunch of ... /, and it's because people are essentially moving to a different part of their computer. Or you can use the absolute path. So this is what it would look like if you were on a Mac machine, where it begins with /user / your username, and then wherever you stored that project. So it might be /downloads or /desktop, etc., etc. One more thing, if you are on a Windows machine and you are working in R, so Windows has a few quirks. In Windows, the / that's being used to denote folders is the \. Yes. So that is the key above the Enter key and the key below this, the backspace key. That is if you're on a Windows machine. However, for many programming languages, that \ means something totally different. It really means treat the next character as a symbol. So like \d would be treated as a symbol of some kind. Or \space for many computers means treat the next, that's how you put a space into a file name. So on a Windows machine, if you are going to use the \, you have to put 2 backslashes in R. Or you can use the /, which is the same key that is to the left of the right shift key, which is also the same key as the question mark, if you're on a US keyboard or whatever, the QWERTY-ish keyboard. This swapping of the two slashes in Windows work in R. You might get some mileage with other programming languages. The main downside here is if you're on a Windows machine, if you didn't know, if you look at like your file explorer, if you end up like in a location, you can copy paste this location. The problem is if you use that copy and pasting, it's giving you this slash, so you have to manually enter it, or you just type it the proper way, like moving forward. So there isn't really like there's like some downside to whatever method you use. So that is something just specific on Windows. I talked about setting your working directory, so we should all be in the proper working directory. You should see the data folder. You should see the ds4biomed-learner R project. And then we will load up our first data set, so don't look at that. So we should have our first project open. I'm going to open up a new script. I'm going to save this script right away. I talked about numbering your scripts. Usually I reserve the 00 for something else. So I'll call it load, and you'll notice that it will by default give the file extension .R. So yeah, I usually start with 1 because that makes sense, and most likely I forget something to run in the beginning, so I reserve 00 for the, oh yeah, I gotta do this other random thing, and I don't have to rename my files. Okay, so we're ready to load up our first data set. I talked about the tidyverse, so we're going to load up the tidyverse. So how do we say like, hey, tidyverse comes with all of these other packages and libraries. How do we enable them essentially on our computer? We type a command called library in a set of round brackets. So library is a function. We're going to tell this library function to do something. Library loads packages, and the package we're going to tell it to load is called tidyverse. If we hit Control Enter, or if we select that, there is a button called Run. We can click on Run, and it will load up the tidyverse for us. It should be really quick, unless you're my laptop loading many things at once, which is probably something I need to figure out for tomorrow. What should come up is, I do have backups for this. Oh wow, that's really bad. It should have been pretty instant on your end, and it should be just as fast on my end, but my computer has way too many things open right now. And there's not much I can do about that. Oh, there it is. Okay. So it's loading up a whole bunch of libraries, so you'll see that like ggplot2 gets loaded. There's going to be a section called conflicts. Essentially what this part means is when you start up R, there's going to be a library called stats that gets automatically loaded. Stats has a function called filter, but part of the tidyverse is also a function called filter. And so it's really telling you that, hey, if you run the filter function, one is overriding the other. So the order of packages matter in R, which is depending if you've programmed before. You will need to, depending on your previous programming language, this seems really terrifying, or this is something you just deal with when you're working in R. Give me 1 second. Okay, so in the tidyverse, there is a function called read underscore CSV. And so we're going to load up our CSV file. I'm actually terrified how long this is going to take, but we talked about files and paths and directories. So we want to go into the data folder. So what you click here doesn't change your working directory. So if you say get WD for get your working directory, this is telling me that R or RStudio thinks this is my starting point. So even though I clicked on my data folder, it did not change the actual working directory. The working directory is really where that R project file is. And so from read CSV, remember what I said about relative paths, we can say we're going to the data folder, we hit slash. In RStudio, if you hit the tab key, usually it'll start dumping out the contents because it's like, oh yeah, it seems like you're trying to access a folder, so I'm going to show you the contents of that folder. That tab key is going to be really useful because it's how you prevent typos. So when I hit tab after data, you can see it populated a bunch of files for us. You can use your mouse or your arrow keys to click on medical data underscore tumor growth.csv. And now if we run that bit of code, it should be pretty instantaneous. Definitely going to make sure I'm using smaller data sets for tomorrow, but you can see it took that CSV file, loaded it into R, and now we have a CSV file. That's great. You loaded up your first CSV file if this was the first time you worked with R. The problem now is we loaded up our CSV file, which is our tumor growth data set, but it's not very helpful because we still don't have any actual reference, or it's not saved to a variable. So if I need to do something with this tumor growth data set, right now I have to reload it again. And so it doesn't make sense every time I make a transformation on a data set, I have to reload the data set. So let's now tell it, load this data set and then save it in R so I can use it again. So I'm going to save it into a variable called tumor. And if you've worked with R before, you'll see some people use like the regular equal sign. If you use this little arrow operator, which is literally less than dash, so you type two things, put spaces around it. That is also another good coding practice in R. So if you literally write or type out this arrow, it says take the thing on the right-hand side, which is this data set that you read, and assign it to the thing on the left-hand side, which is going to be a variable called tumor. And so now if I run that, the same type of things get spit out on the screen, except now it's not presenting my data set, right? It's not dumping it out to the screen. But what you'll notice on the top right-hand side, the environment tab now has a variable called tumor, and it's called tumor because that's what we called it. And it tells us this variable, this data set, or this thing that we saved has 574 observations with 5 variables. And if we click on any part that's not this actual blue arrow, so what I like to say, like click the thing that looks like an actual spreadsheet, it's going to run a command called view, but it's going to open up a little tab for you so you can actually view your data set as if it was a spreadsheet. So you can look up and down. RStudio has a little filter thing, so if you want to filter on certain things, you can. You could pop this out into a new window if you need to look at your data set as you're working on it, but that's how you look at your data set.
I have a question.
Yes, what is your question?
I've just started using R the other day, and I was loading in a data set that had an entry or a cell that had a huge, it was like a question from a survey. And I was wondering, is there any way that you can sort of like, it was very hard to scroll through anything, almost like impossible. It was like a glitchy thing. Is there a way to go, once you're looking at that sort of spreadsheet type with the tumor, maybe like changing the size of, like in Excel you have like a minimize.
Yeah. Okay, so the question was, if you load up survey data, I literally, like for my dissertation and all this stuff actually has survey data. yeah, survey. Essentially, they dump the entire survey question as part of the actual the header. And how do you deal with super long file column names? So in the view part, there isn't really an option to make this smaller. There are part of the read CSV function allows you to rename. You can like give it like, instead of the entire question that's presented, you can give it another thing that says Q1, Q2. You can rename it that way. The other thing you can do, if you know, because eventually what you're going to have to do is reference that column. And the way you reference the column is you have to type it all, like provide the name of the column. So what you might end up doing, and this is one of those things that you might end up doing in Excel because it's easier to do, is you'll have a Excel file that has two columns. One is the actual, like, whatever gets loaded as question one, which is like, what is your birthday plus 57 days? Let's say that's your question. You might have another column that essentially says like, this is birthday plus 57. Like that's what you'll end up renaming it to. Or it might be like Q7 or something. You can load that other thing into R and then essentially use that as a table to rename your data set. So that's what you would do if you have these super long like variable or column names. That's what I do if it ends up being that bad, like essentially like huge questions. Think about how your data gets exported. So I know in Qualtrics there's a way to like export the question number, not just the full-blown question in the title. In Qualtrics, there's also, if you didn't know, there's also a library in R called Qualtrics with a capital R that you can connect to Qualtrics and just pull data straight into R without having that weird intermediate. In Qualtrics, I'm assuming you're using Qualtrics. I'm sure there's like a SurveyMonkey version, and there's definitely a Google Forms version. There's also a metadata data set that exists on the Qualtrics side, so that will actually give you the number with the full question. So I use a combination of the two. Like, I'm going to refer to everything as Q7.3, and if I really need it for plotting, I'll look up the metadata file, and then I'll have the full question if I need it. But in my actual code, I use everything from like the shorthand version. But the answer to your actual question, is there a way to make these things like not take up as much space like you can in Excel? Like the short answer is no. And again, that comes from the fact that this is not a spreadsheet program, so you can't do like visual things. It's just saying like, here's your data set, here you go. So that's sort of where that limitation is. I have a question on the chat side. Give me 1 second. If you ever where's that echo coming from? If you ever like want to come back to the materials and you don't have R installed on that particular machine, so there is a section on the actual setup page called Binder. And if you go to the Binder section, and this is literally because someone is having problems. If you go to the Binder section, there's literally a button that says RStudio complete, and it says launch Binder. If you click on this button, what it will do is open up an RStudio session with that ds4biomed thing already downloaded and unzipped for you, and you can run RStudio in the browser. The downside is the files that you create don't really persist there if you like restart or close your browser window. But yeah, so if you're having issues with some kind of installation problem, use the Binder instance. If it's the first time someone in the world is opening it for the first time, it might take like a minute, and it will take like 15 seconds afterwards. So use that if you are having problems on that end. All right, cool. So one other thing that's really useful in the tidyverse, so in the tidyverse they have a lot of packages that if you, like everyone here, we ran the install tidyverse library, and you notice that like it it took a minute for it to like actually finish. Part of that is because Tidyverse bundles a lot of other libraries together. One of those other libraries is a library called readxl, if I spelled library correctly. And so this is a library that allows you to load and import Excel files. One other thing you'll notice that it's a good habit when you're writing code that all of the libraries that you use, put it at the very top of your code and don't just like, oh, I need it now, and on line 57 I'm going to make this library call. This way, if you hand your code to someone else, they can, just looking at the top, make sure that all of the code that they need, all of the libraries that they need are already there. It's very possible, let's say for example, line 20 on your code is something that takes 10 minutes to run, and then on line 15 you have a library call and they don't have a library and to finish the rest of your code, so they're going to have to install everything. Sometimes their computer restarts and they sort of just wasted that 10 minutes for that one calculation to be done. And so you want to be a little bit nicer to yourself and other people, especially if you just got a new computer. Put all of your library calls at the top. And so what we can do is we can load in another data set, and we'll save it as tumor _ XL. So we talked about how computers don't like spaces. Variable names cannot have a space in it. The computer will literally treat it as two separate things. So you can't have spaces in variable names. Another thing variables can't have is they cannot start with a number, so they have to start with a letter of some kind. So you can't have, for example, 1Q for question 1. It has to be like Q1 if you want question 1. There are some exceptions to those rules, and one of the data sets we load will have one of those exceptions because it has like 2000 as a year as a column. And then you'll notice because it begins with a letter, because it begins with a number, there's more things you have to type to make that work. All right, so I am going to end up closing the captions because it is falling far behind and it's probably killing my computer. So I'm just gonna turn that part off and we just won't have that. If anyone here needs accessibility requirements, please let me know and we'll figure something out. I might end up setting up this other laptop to do captions or something. I'll figure that out. All right, so in Tidyverse, if we load up readxl, so remember you actually have to run this line of code, so you can select it, hit run, or have that line entered and hit Control Enter. In readxl, there is a command called read _ Excel. And here, just like read CSV, we can point to an Excel file instead of a CSV file. So the same relative path thing that we've been talking about, but now Excel files end in XLSX. And so now I can point to that Excel file, and part of the readxl function, so if I put my cursor between the L and the opening bracket and I hit the F1 key, is that right? Or is it taking a while? Oh no, it's just taking a while. If you hit the F1 key, it will, this is the keyboard shortcut for opening the help command. Part of the readxl file, so you'll see in usage, there's the readxl file. You can also use XLS or XLSX, doesn't really matter which one you use. But there's another parameter called sheet. So if you have multiple sheets in an Excel file, you can totally just load up a particular sheet. But by default, I believe it just loads the first one. So that's another thing you want to think about. In general, I am very pro just make a separate file for every single one of the sheets, but sometimes it's just easier to email someone one thing and have them deal with the 50 sheets that are in there. I'm more against that, but you know, sometimes the people you work with, that's sort of like what you have to work with, or that's just what you're given. And so just like how we loaded up the CSV file, if we click on the little part here, we ended up loading up the Excel version of that. And these two things, so if we look at what this thing is, if you ever get confused in R, like you just assign something and you're trying to figure out what is this thing that I just loaded up, there is a command called class. Some of these things are just things you eventually learn over time. And if you give it, for example, you pass it the tumor variable and you run that, it's going to tell you that this thing is a data frame object in R, and it's a special type of data frame because we use the tidyverse to load it up, so it's called a tibble. So that's just one of the things. But if you see something called data frame, that is a square rectangular data set that you loaded into R. All right. Cool. Are we all good up until here? We've all loaded up this tumor data set. That is sort of the most important thing. Yes?
I downloaded the tidyverse and then I ran this tumor Excel. Read Excel says read Excel could not find.
So if you try to run read_Excel, you have to actually do that. So tidyverse loads up. If we can kind of go up at the beginning, it loaded up a bunch of things for you on default, but one of those things that didn't load for you was read Excel. So that's sort of why. If you end up with a command not found, you either typed it wrong or you didn't load up the library that it contains. So one of the other questions that I was getting was if you get a message, so the actual question in the Zoom chat was like, if you get an error in tidyverse, that's because something wasn't installed properly or versions were clashing. But sometimes you'll get a message that says some package was built under R version for some other version. That really just means you installed R and upgraded R, but you didn't update the packages, and it's going to tell you like, hey, like you might want to reinstall all of your R packages again. And so that's sort of the warning for that. But the actual message in chat seems like there's some other thing that ended up happening that just broke your installation. Okay, so we should all have this tumor data set. If you want, you can use the Excel version. Both, that's kind of cool because once you look at the actual thing in here, so if we look at tumor and tumor Excel, you'll see that the thing that they both are, even though they came from different sources, is that they're both data frame objects. And so once you have a data frame object in R, a lot of the things are going to be the same. And so the stuff I'm going to show you right now will carry over depending, it doesn't matter how you loaded this thing. And so the first thing I'm going to show you is how do we pull out certain columns. It's very common that you load up a data set, it's got 50 columns, you really only care about a subset of them, and so how can we do that? So in the tidyverse, if you have that loaded up, there is a command called select. And select is the function that we use to select columns. So the way we use select is we first have to tell the select function what is the data set that we're working with. So we can say tumor, or you can use tumor Excel, doesn't matter. And then we give it a comma. So a lot of stuff in programming language, the way we split things up, if it's not by a space, it is by a comma. So that's how we specify, like, here's the next item in this list, or here's the next item in a multiple item sequence. So if I just say, for example, I only want the size, because the column begins with a capital S, I have to say I want size with a capital S. And if we run this little command, we get a subset of our column that is just the size column. I'm going to end up doing a lot of copy and pasting, but so when you get the code afterwards, you see how it builds up. But if we want to have multiple columns, all we need to do is put another comma and then specify what other columns we want. So let's say we also want group day, And now if I run that bit of the command, it will give us size group day. And it doesn't matter what column order that is in, whatever I specified, that's what it will give back. So even if I did something like put in day twice, I don't know why you would. If you put in a column twice, maybe it doesn't do it anymore. It used to give you that thing multiple times, so I have to figure out why it's not doing that. But that's how you will select different columns out of your data set. Another thing you can do, so if we look at our column, let's say from ID and size. So it's really common if you're working with survey questions that you want everything from like Q1.3 to Q1.9. You want that entire range of columns. So if they are in a sequential, like if they are actually next to each other and you want that whole range, it's kind of like annoying to type it all out. So in the tidyverse, there is a shorthand for this. So we can say select tumor, and then it is case sensitive, so that's one thing you have to mention. So I can say ID, I can put a colon, and I think, what was the last one that I talked about? It was size, S-I-Z-E. And so I can actually say like start from ID, go to size, give me all of those columns in between, right? So that's one of the nice things with select, and we'll use that again. So it's nice that I'm showing this to you now. So this is super useful if you're working with survey data, because most of the time you're just like, I just want this whole block, please give it to me. What you can also do is specify a range and then specify individual columns as needed as well. Part of this process, you can also reorder columns, so it's really useful to have an ID as the very first column. Sometimes it ends up at the last one, so you can kind of use this as the, I want the ID column first, so you can do that as well. In the tidyverse, there is sort of a convention that has shown up that's using this thing called a pipe operator. If you've worked in R, you may have seen this before. It is literally the percent greater than percent symbol. And so what this would look like, let's say I'm taking this exact code that I just wrote before. Instead of putting tumor as the first item, I put tumor as its own separate item. And then I say I pipe this into the select function, and there's usually like a tab or a white space. So if you end up saying percent greater than percent and you hit enter, it will automatically indent that for you. That indentation doesn't really matter. It's really just helping you read this code a little bit nicer. Not really a big difference in time saved. Both of these lines of code do exactly the same thing. But what the pipe operator is doing is it's taking the thing to the left and putting it in as the first thing to the function on the right? So saying select tumor ID colon size group is the same thing as take tumor and put it into the select function, then pass in ID colon size group. So these two things are exactly the same, and you'll see that if you Google any tidyverse help, people use this pipe function everywhere. The other benefit of this, you can see if you start growing your code, and we have an example as we learn the next function, is if you sort of look at that word tumor and all you do is look down your code, you can get a general sense of what's going on. It's tumor select, right? You don't have to, if you've done math before, you don't have to like f of g of x and sort of parse out what is the innermost function before you work your way out. It's sort of you can sort of read it more linearly. So the next function I want to show you, so I showed you how you can pull different columns out of one another. The one thing, actually, let me go back a little bit. The one thing I didn't show you, and right now, let's say this is the subset of our data set I want to keep. All I've been doing right now is subsetting it and dumping it away, right? That's why it's showing up down here. So remember, you can always save this back into something. So I can call this tumor subset. I can save that into a variable because maybe that's the thing I actually care about and I want to reuse over and over again. Remember, you can always use that assignment operator, that arrow, to save it. And then you have that thing on your right. And then at the very end, I'll show you, you can either save that thing as an Excel file, save it as a CSV file. So if all you do is I have this data set that's 500 columns and I only want like 3 of them, load it into R, select the 3 you want, dump it back out into CSV or Excel, and then you don't have to wait for Excel to take like forever to load that thing up for you. So the next part I'm going to show you is filtering rows. So I showed you how you can get different columns out of your data set. Let's say if we could think about that spreadsheet example of like, hey, if your blood pressure is greater than 140, let's like flag you out. Let's pull you out of our data set. So now let's look at what it would look like on how to filter rows. Instead of the function select, the function we're learning is filter. And this behaves very similarly to select. And this is why tidyverse is kind of nice, because the first thing that goes in is always a data frame object. So we can pass in the tumor data set. And then we specify what do we want to filter on. There is a column called group, right? Group with a capital G. So let's say we want our data set for all of the rows where group is equal to 1. And in most computer programming languages, the single equal sign stands for assignment. It's essentially this equals operator. So the single equal sign means like set that equal to something. If you want to check for equality, it is double equals. The way you pronounce it is still equal, or some people will say equal equal if they're teaching this concept for the very first time. But we can say, give me the rows in a tumor data set filtered in such a way where group is equal to 1. And now you'll notice that I have 97 rows by 5 columns. That's what that subset is. And our original one was 574. So in this particular data set, I believe group is the control group for this tumor data set. And a little bit more about this data set is this comes from one of the pre-built-in library. Sorry, it's not pre-built-in. So there is a physician named Peter Higgins up in Michigan. He is I believe he's a GI doctor. I don't know if he's a hepatologist, but he's definitely in GI. And he's put together an R package with a bunch of medical data sets. Instead of loading up his package, I dumped it out to a CSV and Excel file, and we're loading it up that way. In this data set for particular treatment group, so it's either control with a group number, a particular patient, and a particular day in the study. They were measuring, I don't remember which part of the body, it might be the liver, but a tumor, and that they're seeing if some treatment is working better than others. So that is this particular data set. So right now what we've done is we've filtered our data set such that we're only looking at the control group. And if I want to write this as the pipe notation, this is the same thing as, so remember, tumor for this particular function is the data set that we're using. So we can say tumor pipe into filter, group is equal to 1. And so those two things are going to be exactly the same. So building on this example, so I'm going to try to just use the pipe notation from now on. So let's say we want the group is equal to 1, but we also want day is equal to 0. So in our treatment group, I only want the patient's, what are the starting baseline values in the control group, right? And so now I have this little data set. It's got 8 rows with the columns that we specified, or all of the columns. And so if that's what you care about, so remember, you can also have done name is equal to, or last name is equal to done if you only have one person with that last name. And then you can theoretically see if all of your data is in one thing, like we showed you in the spreadsheet data set, it's much easier to say like, okay, you can essentially see how we can pull out the size column and then take an average or something of it. So right now we're on the way of calculating, if the question was like, what is the baseline value for all of our control group participants? We're sort of building our way there. One way, yeah.
I have a quick question. So if you do the piping and you do a second line, can you also pipe into a second line? Or does it just work with the line right underneath?
So the question was, if you do piping, can you pipe, like if I had something else underneath, can I pipe again? Yeah, so you can totally pipe this like into something else. Whoops, had my finger on the wrong key. So you can totally pipe that into another thing. We just don't have, you still have to pipe the symbol again. Yeah, so essentially it's saying like, okay, the outcome of this was this thing. This thing's a data frame. If the next function you want to use also takes a data frame as its first input, then you can just pipe that again. And so that's why I like teaching the tidyverse, is because a lot of the functions, that first object is a data frame object. So you see tidyverse being piped one into another, and then you end up reading like, I just showed you select. You can take this, pipe it into select.
Okay.
So you can just keep going down the list.
But if you wanted to pipe tumor into something else,
If you wanted to pipe tumor into, what do you mean by something else? Like
another function.
into another function? Well, you have, if you want to pipe tumor into another function, the first thing you would have to make sure is like, does that other function take a data frame as input? So, I don't know if so there is a built-in mean function in R. I'm not sure what it will do. Yeah, so the mean function doesn't take a data frame as input. It's just like, okay, you gave me a data set. A data set can be, it's not always just a set of zeros, set of numbers. So it's going to be like, I have no idea what you're doing. So the pipe, all this is doing is essentially rewriting the code, like literally under the hood, it rewrites your code as that. And so if this doesn't work, which I believe you'll get the same error message, then the piping wouldn't work.
Okay. But the piping symbol only works on the next line.
Yes, yeah. So not really the next line. I think it's like the next actual executable line. So if you have like white space, it'll know, and I think you can get away with having like a comment in there. So what is it? Filter rows. So I believe this will work too. Sometimes what you will have to do is like select everything and then hit run, because it sometimes, I mean, it's clearly not happening now, but sometimes it might not realize that like, oh, you wanted me to pipe into the next row, that thing is empty, I have no idea what you're doing. So I don't know if multiple, maybe one line or white space might work. Sometimes two white spaces, they kind of, oh yeah, so there you go. Yes, so day is equal to 0, the number, not O, the character. That is definitely a part of the data set. One other thing you'll notice, and this is tidyverse specific, if you load, so there's a built-in version of read_CSV, and if we didn't use tidyverse at all, it's called read.csv instead of underscore. You get a regular data frame without all of the tibble features. So a tibble sort of will tell you the number of columns and rows. If you have a lot of columns, it'll tell you the columns that it's not showing. What's also nice with the tibble is underneath a column, it'll tell you the data type. So a character for CHR says that this is just characters. DBL stands for double. Essentially read that as a number. It's really a decimal number under the hood. That's how computers do it. I think by default, if it's a number in R, it is by default a double. That is just the type of number it is. And so that's how you know this is a 0 and not a letter O. If it's definitely being read as a number, then that thing that looks like an O is definitely a 0. So one other thing, so keeping with this piping notation, you'll notice that the way I wrote this was, and the way it's filtering our data, it's treating it as an AND operator. So it's like, where group is equal to 1 and day is equal to 0, right? So another way you can write this, if you want to actually like use these Boolean operators, you can type in the ampersand, which is shift 8. Is it 8? No, sorry, it's 7. Shift 7. You can put in the AND operator if that helps you like see what is going on. So you don't have to use the comma. The comma in the filter function is being treated as the AND operator. But I mentioned that because let's say you want the beginning and the middle of this study. So you want group 1, day is equal to 0, or day is equal to 13, right? If I say day is equal to 0 and day is equal to 13, there's no observation where there's day 0 and 13, right? So the reason why I talked to you about this AND operator is because that's how you use a different character for the OR operator. The OR operator looks like this. So it is shift and then the key above the enter sign. So it is the key that it looks like that vertical pipe. I believe up until today, there's like very few reasons why, if you've never programmed before, why you would ever use this key. And so think of this as, I believe you can use parentheses to make things a little bit clearer. Yeah. So what I did was I wanted to filter my data set such that group is equal to 1. So this is the control group. And then just to make it super clear, I put another set of round brackets. In that set of round brackets, I'm saying day is equal to 0 or day is equal to 13. And so now I have a data set where for every patient, I have the value for 0 and then essentially the middle of the study, which I just picked 13. So now I have those two things. Yes, question?
So when you're looking at this, it looks like there are participants that maybe they dropped out.
Mm-hmm.
Is there a way that you can filter so that you only capture the participants that are both in 13 and 0?
So the question is, some of our patients dropped out. How do you filter on that? That is going to be a question for tomorrow. I'll talk about it in this way. The way the data set is structured right now, if we look at each individual row, there's no way to tell if that patient also has another observation, right? That's sort of the problem with the format the data set is in now. The way we can answer the question of did the patient completely finish everything, there's a few ways you can do it. One way is if we had a separate set of columns that was 0, 1, 2, 3, 4, 5, all the way up to 20, 28 or 30, depending on how many people, whatever length of the study is, then it would be easy to say, give me the rows where there exists a value for column day 0 and column day 13, and then you can filter things out that way, if that makes sense. It'll be more obvious if I, let me see if I can draw this on the board. I apologize to the people on Zoom. So right now our data set looks like this, day 0, 13, and then there's like a value, I'll say like 4 and 27. It would be nice if there was a column called day 0, day 13, and then 4, 27, right? And then I can say, for that row, if there is a value for 0 and day 0 and day 13, then I can filter it and then turn it back into that. That's how I would do it right now, off the top of my head. And I'll show you tomorrow how you can just do a pivot, filter, and then just pivot it back. So that is like one of the crux, like nicest things about using R, because you can just do these transformations, and it's one of the fundamental data processing things to know about. So we'll do that tomorrow. And okay, so now let's keep building on this example. So I showed you about the piping example. So we can take this data set, pipe this back into, let's say, select. Maybe I just want ID to size, right? Because I know that this group is all the control group. I don't care about the other columns. So I can then pipe this back into just selecting on ID, day, and size. Right? So I'm shrinking, I'm taking what I need, and I'm filtering my data set down to what I need. Other things you can do, I'll just keep building on this example because we can. Let's say you're at this point in your data set. There's nothing wrong with using another filter statement. You can reuse functions as you're building things up. Maybe it doesn't make sense to put it all into one filter call. Maybe it makes sense to do some other stuff in the middle before you filter again. So other things you can filter is like, let's say I want to filter all of these rows where size is bigger or greater than 100. You can do that as well. So what this will do is it'll filter on the group and days, then it'll select the different columns, and then it'll re-filter off of that all of the values that are greater than 100. And you'll see here that the values that come up are on day 13. So essentially, no one's tumor in this group at day 0 is greater than 100. Right? So depending on the question you ask, you can build on these things. And right now, the way I've been doing it is sort of just running it in real time. That's why the output is coming out down here. Again, don't forget, you can always save this. If this is something that you want to work with later on, save it as a variable, and then move on from there.
That can say that I can't find ID in the column, even though I can see that was the last thing that came, the column that came out.
Is it ID both capitalized? Did you spell it right?
Yeah. And the size is also capitalized.
Hold on. This is what I get to do. Totally miss.
But anyways, in case
You have to type it in. So that, yeah. That's the one thing I totally miss. If you have actual help, there's like way easier, instead of just taking over everyone's Zoom screen and publishing like what your problem was to the world, you can just run over to someone. Okay, so let us take 5 minutes. What I want you to do is take the tumor data set. Take that tumor data set. I want you to filter just on group, ID, day, size. So I'm purposely like not typing the, just get these columns, and just the rows where day is equal to 0 and 13. So write the code for that, and I'll give you about, maybe not really 5 minutes. Yes. So it's like, this is a data set that needs to go to there, but because you didn't tell it to put it in there, it was just like, I don't know what is, because then it's treating this as the data set. Yeah, it, so literally like, what is the non-technical way of typing? Like input machine, output becomes as input for the next machine, so that's what we're doing. So for the folks on the Zoom side, I guess use some kind of +1 or the green check mark or some indicator if you're ready to move on, or if you have any questions, just let me know. Okay, so one other question that I was getting, um, I don't like using overly simple examples, but here it goes. Let's say I want a variable called x that is given the value 1. And this applies for that whole entire piping thing. Yes, I've seen some people do the whole like 10, like, you see how the pipe arrow is pointing to the left? Like, you theoretically, because R is super weird, you could use the other pipe arrow and that'll turn x into that value, and in theory you can use that as a pipe operator here. I only said that because someone mentioned it, like, can you have the arrow point the other way? It's like, yes. Usually you will see people write their code this way with the arrow at the top instead of the arrow at the very bottom. And that is sort of by convention, and the more people who do a certain convention, you just essentially kind of just roll with it, because if other people see it, they're gonna be like, what are you doing? Or like, I didn't even know that worked, but apparently it does. Now I have to be really careful with the rest of the stuff you're writing, because what other wonky thing are you gonna be writing? So that's sort of, you might see that occasionally. So the short answer is yes, you could use the other operator. And the other answer is, I'm not even going to save that there so no one sees that. So just forget that, but that was a question that was asked. So, okay, so the answer to this result, so the question was, can you take tumor, select those columns, and filter on those rows? So the answer is tumor. I guess, like, really, I just gave you the same exact question that we worked with. So the select function works on columns, so we are selecting on group, ID, day, and size. So I'm typing it all out. If you use the colon operator, that's totally fine. And then we are filtering on day is equal, sorry, it's capital D, day is equal to 0. And if I forget it, like, you'll see if day is equal to 13, it's going to give me an error saying day not found. And so usually if you know that column exists, you probably typed it wrong. So that should give us something. What other thing did I mess up? Why do I have 0 columns? That doesn't make sense. Alright, so let's work on this in separate things. Oh, sorry, it's not day, it's not and. Yeah. Alright, cool. Live coding. So it's not day, it's not and, because even though I mentioned it, I'm still going to type things wrong in front of you. But yeah, it's an or, because, again, there's no such thing as day is, that value doesn't, it's impossible in the way this data set is formatted to have a value for 0 and 13 on the same day. Okay, so we have this small data set. Notice that from the previous example, I was also filtering on the group, so group was equal to 1, but this one doesn't. This one has many more rows, because we're also having the other treatment groups. So let's say the question is, hey, I have this data set and I only care about the beginning and middle of this study. Maybe some people don't make it through the entire study. If that's the problem that you have and you're working on that type of question, that ends up being if that's the type of statistical problem you end up working on, that is a survival analysis problem. So that is just the words you look for, how to do survival analysis in R, and then you can work your way there. So we're going to save this data set. So I will save this as tumor underscore subset. So notice that before I also had a tumor subset from a previous example. If I use the same variable name and I run this bit of code, it is, and if I spelled both of them correctly, clearly I didn't. What did I save this as?
You've got the S in the other subset.
Oh, wait a minute. Hold on. Subset. There we go. If I had run the same variable name, you'll notice it will overwrite the other. So that's one of the other things I talked about is you want to make sure that our data on load wants to be not to there, because that's stuff that can happen, right? You think something is going wrong, you want to turn everything off and put it back on. Turning it back on just loaded everything back in, which didn't really turn it off to begin with. And so now you're trying to figure out like, why there's no day 20? I just loaded up my data set, like, and it's all started from scratch. So that's the reason why. I don't think people run into the problem where like they're working with such large data sets that like that load up time from RStudio becomes a problem. I don't think that's really that much of an issue. If it is, you might want to think about working on an actual database instead of like actual flat files that get passed around, because that's where you get performance there and you don't have to reload the data set there. That's something you might want to think about. What's also really cool about tidyverse code is if you do have to work with a database, and let's say this tumor data set literally exists in a database thing that your university, company, lab hosts. Let's say it's like Postgres database or Redis or some other database thing. Once you make that database connection, and let's say you make the connection to the tumor table in the data set, this rest of this code doesn't change. Like you literally just plug in the database connection to that data set, and literally tidyverse will understand, hey, that's a database connection, this is a data set, it has these columns. You literally don't change any of these lines of code. It will just give you back a data frame, even though you're working on a database connection. So that's really cool. All right, so next thing. So I showed you about read underscore CSV. There is a function called write underscore CSV. There is a CSV 1 and 2, or CSV and a CSV 2. That is literally because certain countries they swap the thousands delimiter from comma to period. There's a separate CSV writer. Then instead of an actual comma, they understand that like if they see a comma in a data set, it means the thousand separator. So that's what the write CSV2 stands for. You could pipe in the value, but typically when I'm using this function, I put in the data set I want to write, and then just like reading in the data set, I want this to go into the data folder, and I can call this tumor underscore subset.csv, and I can save this file. And now if I, on the right hand panel, look at my data folder, and sometimes you might have to click that refresh folder, you should see that tumor CSV, tumor underscore subset is there. There's another library called write.xl. It doesn't come with tidyverse. Part of that is reading and writing Excel files is more complicated than it seems, and sort of a nudge to not write Excel files is they just made it a totally separate thing that other people not from RStudio maintain, because they want nothing to do with that. So you have to install another package called write, the letter X, the letter L for write Excel, and then from there you'll get a write underscore Excel function if you want to write Excel files. It will also give you the ability to write to specific sheets in an Excel file. So if that's another thing you need to do, like your boss or your other colleague needs an one Excel file, you can do all your work in R and just give them the thing that you write out, and then they won't even know how you created the thing. So that's really nice. So I'm going to save this file, and what I'm going to do is I'm going to go to the top corner, create a new file. And so this is sort of, when we talk about data pipelines, this is essentially what it is. You have one script, it reads in a data set, it does some things, it writes out to a file, and then the next piece of the pipeline, don't just keep adding to this R script. It's really scary if you're like, oh, I just came back from vacation, let me go work on my project, and it's got 1,000 lines in it. That's kind of really terrifying. So it's totally okay, and I think tomorrow when I reintroduce things, I'll show you some of like the work that I do. It's totally fine to have an R script that literally has 5 lines. All it's doing is reading something, filtering out data sets, and then writing it out back. Essentially for my dissertation, for all the survey stuff that hopefully you guys take. That's what I do. I pull information from Qualtrics. I only take the columns I need. Essentially Qualtrics has other weird columns I don't care about. I anonymize everyone's responses, so you just get a numeric value, and then I write that back out to a CSV file, and then I can start the rest of my analysis. So in reality, I don't even have, none of the other columns that I don't even get stored on my computer at all, right? So that's another way you can work with like certain privacy things where like it's not really that much of a problem. Like I could see it, but it never gets saved anywhere, so you don't risk it being captured by someone else.
Do you end up using Python for your analysis?
So question is, do I use Python for my analysis? It depends on what. I know how to program in both R and Python. So for me, if I look up a tutorial online, if it's written in one or the other, I can sort of deal with it. In actual practice, there isn't really anything that exists in one that doesn't exist in the other. There's certain things like in Python, you might be able to do more like parallel compute stuff a little bit easier. And so if that's a thing you need, maybe you work on that. But from Roberto's like survey like a month ago, like it was overwhelmingly everyone in this area wanted more R things. So we were just like, oh, you probably want R because you either work with people who use R, or you've seen something cool that was done in R and you want to replicate that, or a lot of things from the statistics world. A lot of new methods get implemented in R first before they move on to Python, and part of it is because statisticians will work in R and not in Python, so you'll see more statistical methods being implemented there first, and then it requires someone else to translate it into Python. And then in actual practice, like there is no real difference between the two languages for data-related work. If you want to build or communicate with hardware sensors, like yeah, you can use Python or C because R doesn't work on the thing, and so that's sort of where the limitations will end up being. But even like making websites and stuff, you can do that in R. So it ends up being like pick the language with the people and support that you have around you, because if you're the only one learning this thing, you're not going to be learning it very very long unless you're super motivated. Okay, so we created a new file. So in RStudio, how do we reset all of the stuff that we loaded? One way is to click this little broom option, but the actual way you want to do this moving forward is there's a session button on the top, and you hit restart R. The keyboard shortcut is Control-Shift-F10, and what that will do, it will clear all of your environment. Why didn't it do that? That's weird. Hopefully it's just my computer like being slow and confused. It should clear everything in your environment. And what I like also, because of this session restart R option, it also unloads any library that you have loaded. So for example, in the previous thing, I loaded read_Excel. And in this script, let's say I want to load up another Excel file. If I actually did a proper reset on my system, if I forget to say library read Excel, if I give it to someone else, they won't be able to load up that Excel file because that library wasn't loaded. But it'll still work for you because it was still actually loaded on your computer. So doing that session restart R is essentially the turn everything off, turn it back on, assuming you don't have that load R .R data into your workspace on startup selected. So we have a new script. We have resetted everything. So we also have to reload our all of our libraries. I realize this is going to take a really long time, just like it did last time. But so this is the process, again, of creating data pipelines. And data pipelines usually are as simple as this is a separate script, and it takes the input from another script, right? So you've heard people talk about data pipelines in the past. It might sound like, oh, how do I actually do that? It's more or less another script that they run that is just the ingesting the thing that just got dumped out. And so for your own work, you know, if it's a GWAS study and you only care about a few SNPs, have a script that is like subset, and all it does is subsets the SNPs that you need, dump it out. So one, you have a file that's just smaller. If you ever need to email this to someone, it's just a smaller file, and you don't have to deal with like weird, like all of a sudden like this gets like, at least at Virginia Tech, like all of a sudden there is like a Google Drive attachment thing being created when you're trying to email something, and it's just like, well, you only need 2 of these columns, and it's like a 30 megabyte file that I can't email. That's kind of annoying. So that's one of the benefits. So now you have a single file that's more portable. It's only the bits that you need. If you need more, go back to the script that says subset, and you know exactly where you need to change. And so instead of having one script that's like hundreds of lines long, you'll have multiple scripts that are like a couple, like dozens of lines long. And that sort of one helps you orient yourself and helps you find things easier. One of the things that I really like to do is if I am making a figure for something, I will have in some part of my pipeline just dump out the data set for that figure, and I will literally just have a script that is just doing that one figure. So if I am going back and I'm trying to find like, oh, I need to update that figure for that paper, I literally just find the one script, and the only code in that file is the code for that figure, and the first line is saying, this is the data set that I'm loading. And so now I can trace back like, oh, if the data set's out of date, I just need to find the script that saved that out. But if it's the data set that doesn't need to be changed, and all I need to do is like tweak, you know, the title or something, I don't have to filter, I don't have to rerun hundreds of lines of code. It's literally like, oh, here's the one line, let me rerun that thing, right? So pipelining is good for just making things easier to find as well. So I'm going to call this 02 stats. It's really descriptive stats, but we'll end with this bit for today. So the first thing we need to do is we now need to say tumor subset gets read underscore CSV data slash tumor subset dot CSV. So all we have done is we use the tidyverse, we use the read CSV function, and we read in a file that we had saved out in a previous script. And so we are beginning the data pipelining process. And in this part of the pipeline, we're going to show you how to create or run certain types of summary statistics. So we have this tumor data set. Because of the way we filtered it, is we only really have day is equal to 0 or day is equal to 13. But for all of our treatment groups, so we have 1, 2, 3, and 4. So we have our tumor data set. Let's say I want to give me the average size of all of the tumor sizes for all of our patients. So at the start of the study. So the start of the study is day 0. So we first need to say filter day is equal to 0. And we can run these parts in little bits so you can sort of self-check your work as you're building this stuff. So day is equal to 0, so we clearly see all of the values here are 0. And then we want to pull out that size column. So here's sort of like small differences. If we want to get that size column, I showed you select to pull out a actual column. So here's sort of like one of the differences about how things get printed on the screen, and use that as a visual cue. If I use select to select the size column, you'll notice that like I get a column of values, right? Like if you think about an Excel spreadsheet, it's literally a column. The function we want to use is called mean. So mean doesn't really take a column of numbers. It takes like literally like a list of numbers. And so this is sort of the difference between like if things get printed like in a column with the column name and everything, that doesn't always work for functions that only take lists of values. In R, the technical way is a vector of values. So if you've taken like linear algebra before, like there is a vector, like a sequence of values, and there is a difference between numbers going this way in a matrix and numbers going that way in a matrix. So same thing applies. So just to show you when I'm copy and pasting, so in tidyverse, if we only want the actual values of a column as list form and not in column form, the function that we use is called pull. And you can see when you run this, you get numbers in a sequence. This is totally different the way it's printed than before. And so now you can see like the numbers in the square, that is the position of that number. So it's like the first element is 41.8. The 12th element is 46.8, and the 34th element is 69.2. And this square bracket number will change depending on how wide your screen is, but it's literally to say like, what is this? What position is this number? So you can say 12, 13, 14, 15, 16. So you have a sense of like, that is the 16th element, so it's helping you count. So that's the difference between select and pull. And now that we have an actual vector of numbers, we can then pipe this into the mean function. And for all of our patients at day 0, the mean of the tumor size is 51.59, right? And so remember, if we go back to our spreadsheet chapter, having a column where there's only one thing in that column that's being measured is really important, because if I had like for millimeters in there, that becomes a problem because mean can't take means of character vectors. It has to be a number. So that's where code books come into play. Maybe it should have been size underscore if you were curating this data set yourself, just so like there's no confusion what the unit size is, et cetera, et cetera. Okay, so building on this example, let's say you only care about, let's say you want to compare between groups, right? So you want to see the baseline for the treatment group and then some of the other the control group and some of the other treatment groups. We can build that into the filter statement. So we can say group is equal to 1. And so now we get the starting average tumor size in the control group. And let's say we want, for example, one of the treatment groups, which is group 2. We could theoretically copy paste and write 2. And now we have 51.8 for treatment group 2. You can keep going to group 3, group 4, group 5, et cetera, et cetera, et cetera. One sort of thing in programming is if you end up copying some part of your code and you end up pasting it like more than 3 times, there's probably a better way to do it. In general, that's probably what happens. Having said that, sometimes to make that part better requires you to learn another skill. So maybe you just don't have time to work on that part now. That's totally fine. But just know that usually when you're copying and pasting your code and you see like, hey, I've pasted my code 10 times and it's literally changing this one number. We will talk about that like not really today and tomorrow, because that's more of a programming skill than a data analysis, like a data processing skill. But just know that there is a better way. Having said that, there is a better way that we can do this particular calculation in the tidyverse. So I know in this data set that there are 4 groups. You might not necessarily know that. There is code that you can write using the unique function. So we can say tumor subset. We can say pipe. We can pull out the group column. So we only want the values in group in vector form, not column form. And then there's a built-in function called unique. this will essentially just say, hey, there's only 4 unique values in here, right? So if we're copying and pasting this part of the code, maybe 4 is okay. And it's not going to be too bad if your underlying data set changes and you end up with a 5th group. But there is another way. If you know depending on how well you know Excel, if you have the same data set in Excel, there's like a button called there's a tab called data. You can click the data tab and all of your columns get like a little arrow on it. Part of that data ribbon, there's like a function called group by, and then now you can create like these grouped operations. We can do the same thing here in R. So let's say the question is, I want to do an comparison of the starting tumor size across all of my groups, right? Let's say that is your question. I want to compare the baseline for groups 1, 2, 3, and 4. How do we go about doing that? So we take our data set. There is a function in tidyverse called group by, group_by. And essentially, you put in group by the column you want to split apart your data in, right? So group by in somewhat more technical terms that carry on to the rest of data processing world, it will split your data by each unique value in that column, so split. It will apply some function. So in our case, it's going to apply the mean function to each one of those splits, and then stick it all back together and combine the results together. So split, apply, combine is what group by is really doing. So what is the column we want to split on? We can say split on group. And then for each unique component of group, what is the function you want it to calculate? In tidyverse, there's a little more code you have to write, so I will write it out and then explain it. You pass it into a function called summarize, and then you can say, I want the new column to be average size is equal to mean of the size column. So I'll run this code, and then I'll explain exactly what it's doing. So right now, the output of this took my data set, found that there are 4 unique groups, split those out into those 4 components, ran the mean function across all of the groups, and then put it all together. The numbers are really big because we have 0 and 13 as part of the average that it's counting. So maybe instead of just group, I want it split open by group and day. And so now, when it runs this part of the calculation, for each unique combination of group and day, it will calculate the average size of that column and put it back together for me. In this part, there are no missing values, so that's okay. So let me talk a little bit more about the summarize function. If we think about statistical functions like these descriptive functions, functions like mean take in a bunch of numbers and give you one number back, right? So that is a summary operation. Compare that to something like taking a z-score of something. A z-score takes in a bunch of numbers, calculates a z-score transformation, and its output is the same number of values it got in as input. So if you have a function that takes in n number of values and gives you back 1, it is a summary function. If it takes an n number of values and gives you n number of values back, it's a transformation function, right? So that's why we have to tell tidyverse or really dplyr, we're performing a series of summary functions, and this allows us to do something. Because it's all summary functions, we can pass in I think it's SD in R for standard deviation. Yeah, so we can pass in other summary functions into the summarize function. If you're in Australia or in the UK, you can use the S, so it's not Z, but you can layer up multiple summary functions. So if you also want, there's a function called quartile, so you can put in different quartiles if that's also what you want to calculate. And the whole magic is if you're putting things into group by, it will split your data into all of those individual groups and then calculate those summary statistics for you, so you have something to compare. Right? Cool. Any questions? That's roughly what I wanted to cover today. There's like 15 minutes left, not really enough to talk about, like, start what I want for tomorrow, but there's more than enough time for everything built in to start that tomorrow. So that's the main takeaway. If this is what you want as like the thing that you want to load into Excel to like plot or whatever, all you need to do is save this into a variable, pipe it into write Excel or write.csv or write_CSV, and then you can write that out and then do your whatever you're good at in Excel or whatever programming language. Or if it's something that you will, if there are people in your group that use Tableau and this is the data set that they need in Tableau, like you can do all of this processing in R, and then I don't know if Tableau has that many data processing features. I don't think it does. So this is a way where, like, let's say this is an ongoing study where you have new people being recruited into different treatment groups. This day 0 number is going to be changing, or because you're getting more patients. Now you have a system where, like, if the underlying data set changes, you can run that load script and run this stat script, and you'll get an updated set of numbers that you can just email back to someone else. And the more you keep into these pipelines, the more up-to-date things will be, right? So if this gets written out to a file, and maybe the person writing the Tableau dashboard is, all they care about is, as long as you put the file with this name in that folder, that dashboard loads up, then you've sort of made everyone's life easier, because nowhere in this process, like once you got it all set up once, it's essentially just automated unless someone messes up the data entry side on their end. But now you have a way where all your data is up to date, and you don't have to worry about that. Cool. All right. That's all I want to talk about today. Leaving early is always a good thing for most people. That's always the goal, to finish early. What I will do as sort of closing remarks is, over there is like a bit.ly link that says bit.ly/ds4biomed-pre_workshop. If you would be so kind. In the remaining extra time, please fill out the survey. My dissertation and or my advisor will be very grateful. But with that, I will break for today. Yes, if you have any questions.
The same one that you sent out?
That is the same one that I sent out in the email. So if you already took it, cool, thanks. But yeah, and for tomorrow, what we are going to talk about is that pivoting of data. There's a lot more things than what I presented on the board there that can be very useful in your data processing journey, and then how all of this ties into visualization. So we should have enough time for most of the basics of using ggplot, and then a pretty in-depth discussion about how logistic regression works. So that is the type of model you use if the outcome you care about is binary, like, did this person get sick, yes or no? So if you can ask your question in a yes or no format, that is the type of model you will use. And that sort of sets the groundwork for a lot of other statistical methods. So that's sort of why we will talk about that. So that's the plan for tomorrow. Please take the survey. If anyone has questions, I haven't seen anything on the Zoom side yet. So if you have questions there, just let me know. Otherwise, enjoy your 11 minutes.